Hey everybody, it is Mr. Ensminger. Unfortunately, my uncle passed away on Thanksgiving evening, and so today, Thursday, December 3rd, I will be out attending the funeral and services for him. Instead of me being here, I provided this lesson on what we would have done. This week we're continuing to do for loops, and so let me give you a few more examples on for loops. We'll start in Python, and you can see here I have Thursday substitute lesson. There is a way of estimating pi, which of course we know 3.14159 all the way out. There's actually a series of numbers that you can accumulate, a sum up, to estimate pi. The pattern works like this. You start with 4 over 1, and then every term alternates, positive, negative. So 4 over 1 is positive, and then we alternate by saying 4 over 3. So the numerator stays 4. The denominator is going to be the odd numbers going up. So 4 over 5 added, then subtract 4 over 7. Add 4 over 9, subtract 4 over 11. Now, of course, looking at this, hopefully you see a loop where the denominator and the terms, they're going to accumulate using a total variable, and we're going to count up to a certain number. Now, you could do this forever, but we're going to keep going up until we get to 4 over, let's say, 999,999. And that actually works out to be a positive term. So, quick little for loop for this. The way I'm going to model it is for d, for the denominator, in the range. And so, what we're learning this week is how to work a for loop. For loops are just like while loops, except while loops are indefinite. We don't know how long they're going to run. This is a definite for loop. I know I want to run from 1 to 999,999. And so, if I do this with a step of 2, that's not good enough because this last number is exclusive. It goes up to but does not include that number. So in reality, I'm going to go up to 1,000,000. Now, of course, 1,000,000 is not in our list of denominators because they're all supposed to be odd numbers, but it's never getting that number. It's going one short of that, which is where the 999,999 comes into play. We're also going to need a total variable, and the total variable is going to be 0. And so this is going to take care of most of our work. The only thing that we don't have yet is the whole plus and minus thing. But let's just, for the moment, look and see what this gives us. If I'm going to print quote 4, comma, well, I guess 4 slash, and then comma d for denominator. Just again, to show you what this gives you. If I run this real fast, I might have to stop because it's probably going to go on for a very long time. Estimate pi. There we go. And let me just pause this for a second. I guess I'm actually not able to pause. Oh well. Well, hopefully you can see this. It's counting for over every odd number. Fun times. Okay. So now, if we average them up, because we don't want to print everything, we want to say total equals total plus 4 over the denominator. But the thing is, we don't always want to do plus. At the end, we know that we want to print out the total, which hopefully that's going to give us pi. And so when we do this, it's just real fast. It's going to give me a very large number. That's not pi. I guess I shouldn't say very large. It's really only 30. But what we don't have the alternating. So how do we alternate? Well, I'm going to make a count because every term alternates. I'm going to use the whole idea of even and odd. Now, I'm not talking about the denominator. I'm talking about this is term 1, this is term 2, this is term 3. So I'm going to say I have a count of 1. This is the term count. So instead of just always adding, I'm going to say if I can take the counts and mod by 2. we've done this a few times. Modding means you're taking the number, dividing, and getting the remainder. So this is going to be for the even terms. The even terms, if I count 1 term, 2 term, 3 term, the even ones are actually subtracted. So I'm going to subtract that, and then else I'm going to say total equals total plus 4 over d. So alternating, even, minus, odd, plus. 1 up to 2, 999,999. Let's run it. And you're going to get, oh no. What happened? Well, what happened was we never changed the counts. These are just the little things you got to be careful of here. The count is 1, but the thing is it never changes. And so what we're forgetting is we need to say count equals count plus 1. Now, when you run it. Oops. That was weird. Try that again. Forgot my 1. Miraculously, look. You get an estimation of pi. 3.14159 off into infinity. Now, if I want to actually print pi to compare, remember what I can do is say from math import star. And so here's my fake pi, my estimated pi. And there's my real pi. And so look how similar it is. It's good up until the 9, and then it's just off a little bit. But I mean, it's not significantly so. The more terms we add, the closer this is going to get to pi. Again, because we terminated it early, but theoretically we could just keep going and add more terms, and that's going to give me more accurate decimal places. So it's an interesting little series that will approximate pi. Okay, so what I'd like you to do in the remaining time, the video right now is about 7 minutes. We should have, 23 minutes if you're on Zoom, 33 minutes or so if you're live in person. I'm going to give you some practice programs to try with the for loops. So try a couple of these. First one, we're going to add the even numbers from 2 to 20. Print each number with a plus sign in between and the final total. Print the series left to right. So in other words, what this thing should look like is 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 equals 110. So try that. If you don't know yet how to print something left to right, it is in the first YouTube video of the week. Not counting this one, of course. This is not technically a YouTube video asynchronous, but it'll show you how to print left to right. We have done it once or twice, but in case you've forgotten, you can check that out. Then, now one second, I've got 2 monitors here. Practice program 2. Print the numbers from 7 to 77 by 7s. And again, print them horizontally. So much like you did here. Now for this one, you don't have to put plus signs in between, but just give that one a shot. Practice program 3. How about let's count down. Print the even numbers from 10 to 2 vertically this time. And then finally, practice program 4. Find the product. So you're multiplying, not adding, but you're multiplying. Find the product of the odd numbers from 1 to 25. Okay, just so a couple quick things to try. We will go over them the next time I see you. Meanwhile, of course, check out the agenda. Make sure you are watching the videos for this week. We're going to continue for loops next week. And thanks again. See you guys soon.